Welcome to Submodule B of the Copernicus Land Monitoring Service. This module will present an overview of the properties and characteristics of the high-resolution layers, which is one of the key products of the continental component of the Land Monitoring Service, together with further information products like digital elevation models and visualization techniques like 3D visualization. And that module should show or give an idea what can be done with this multitude of data, how you could creatively combine this, what applications you could think of. As an introduction, probably one should mention that the high-resolution layers are, basically produced in 20-meter spatial resolution, and they provide not only land cover information, but provide specific characteristics of land cover, like density of impervious surfaces, like information on tree cover density per pixel, like information on forest type distribution in terms of coniferous and broadleaf forest, and also information on grasslands, wetlands, and permanent water bodies. So these 5 high-resolution layers can be also combined with other sources of data, like a digital elevation model. In this case, we use the EU-DEM, which is the European Union's digital elevation model in 30-meter spatial resolution. And we also use ancillary data sets which enable to implement further value-added applications. The use case specifically aims to show the combined value of these data, both of the height information and the thematic land cover information for various kinds of applications, for cartography, for modeling, for all kinds of spatial analysis, for image processing, and so on. In this case, we aim at creating a 3D visualization, and that can be used for, basically visualization purposes, but also for all kinds of analysis and interpretation. These datasets are all freely available and can be relatively easily combined with commercial or freely available GIS and image processing software. As data, we use the high-resolution layers from the reference year 2012. We used the European digital elevation model in its latest version. Also the image mosaics, which are available in a pan-European fashion in both high resolution and very high resolution in a mosaic format. So that's both in true color composites and also false color composites, and I'll show later. We use additional information like the EA reference grid. So that's basically a spatial gridding system in a European uniform projection in various grid spacings like 1 kilometer, 10, 100 kilometers that can be used for various kinds of assessments on a grid-based level. And we add further information for visualization purposes like the NUTS levels. That's basically the administrative boundaries on various administrative levels across Europe, plus information, for example, on airports, ports, and so on. So the overview of that demonstration that I'm going to give you will be how to download the data, how to visualize these data in a 2D environment, how to also visualize in a 3D looking environment, and last but not least, there's one example of how you could integrate all these data into a flight simulation in 3D mode. So in terms of download, most of the data are directly available from the Copernicus Land Monitoring portal. The address is given here, land.copernicus.eu, which discriminates or presents the Copernicus Land Monitoring Service in its 3 main components: the global land monitoring component, the continental or pan-European component, and the local component. Additionally, there's also further information from the in situ component related to land cover, also available via that portal. So when we now go to the continental component and click further in to the high-resolution layers, you have this selection of the imperviousness layer, the forest layer, grassland, wetlands, and permanent water bodies. Basically, for the purposes of this exercise, we take all of them. They can be downloaded after registration on the portal, either as a whole or in section. As next step, we download the European reference data that we need for that exercise. In this case, it's the European Digital Elevation Model. We use the latest version 1.1, which you can download also in tiles. So that allows you to have digestible portions of data that you can make use of, because this is a relatively big data set. And there's further data or vector products like the EEA reference grid that I mentioned, which can be downloaded from the EEA's webpage. So the address is given here, eea.europa.eu, and you go to Data and Maps, and in the search field you type reference grid, which leads you directly to the download page of the EEA reference grid, which you can select in either a 1 kilometer or a 10 or 100 kilometer spacing. As a next data set, you go to the Eurostat website, where we want to download the administrative boundaries of the NUTS data sets. So you go to Data, you select the GISCO geographic information, then you get an overview page which explains to you which kind of data, which kind of NUTS level, which depth of administrative boundaries are available for all of Europe, which varies quite a bit over the countries. And then you see the different kinds and different update time steps of the NUTS datasets, which we also download in the latest version. Now we got a lot of data which we can visualize in a GIS, in a geographic information system. Let's start with just a few basic ones. First one that's being shown here in different colors is the digital elevation model. So you have the green tones which represent low altitudes, and the brownish and white tones which represent high altitudes. So you may recognize the area, it's the Peloponnese in Greece. We have added also further information on airports, which are located just in various spots around Greece. It's a holiday area, of course, there's lots of airports, and there's also lots of ports because it's in the Mediterranean. Now you can overlay that EA reference grid. It's a 10 kilometer grid in this case. You can overlay the administrative boundaries, which are the regional boundaries between the administrative districts. And you can overlay also the Copernicus high-resolution layer products. In this case, what you see here is a combination of all the 5 high-resolution layers, showing in a synergistic manner all the high-resolution layers at once. So, in more detail, of course, reddish areas are settlements, urban agglomerations. So this is the city of Athens. There are greenish areas, which are forest areas, with the light green being broadleaf forest and the dark green representing coniferous forest areas. There's bluish areas in inland areas, which are water bodies, lakes, river courses. And there's further areas which we will see soon, which are representing wetland areas. So what I'd like to show you finally as a final highlight is a short flight through this landscape in a 3D environment, which you can also visualize with GIS software when you have all the data integrated. So you see here the flight line. We go along the Turkish coast and over all the islands towards the Peloponnese, over the Peloponnese towards Athens, and let's go right into it. First, I need to mention there's 2 options of displaying the background landscape. You can either use the false color images that are available in 2.5 meter resolution image composites from the Copernicus data, or you can use the true color composites, which is a more natural appearance, but doesn't provide that depth of expert information on the state of the vegetation. For our purpose, we chose the natural true color version, and it looks like this. So we start along the Turkish coast, and what you see is that you have both the information on the elevation in this GIS environment combined with the thematic information on land cover and land use, which is overlaid to the 3D environment. Reddish colors representing different degrees of density of impervious surfaces, blue representing lakes and river courses and inland water bodies, the pinkish areas here representing coastal wetlands and also inland wetlands, green you see are especially represented in the higher mountain ranges where there's still forest stands, both coniferous, dark green, and broadleaf forests, which are the light green areas. And so you see that with these kinds of simple, freely available data, you can do all kinds of sources, animations, applications, and there's certainly a lot of other further applications one could think of. I invite you to use your creativity to make some cases, to make some applications out of these great products, which are available for download, free of charge, for a variety of landscapes all over Europe. And I thank you for your attention. Thank you. So